So based on the previous example, which you've seen with the card, now you've seen the streams with the input-output stream as well as the exceptions for your files. Okay, so what you've seen before with the Java IO, even for the file, this existed also inside my client inside, or whenever you have this storable, as you can see, you have your output for input-output operations. And this means that for reading from, let's say you have a hard disk, you have an internal memory, as well as you can output, so you can read from the keyboard and so on. You have all this stream such that your processor will also use all the buses in order to get connected to them. So here, based on the package of Java IO, what you can do is that each and every information that you've got is stored as a bit. And based on the bit, you've got your bytes and your octets, okay? And then you have all your memory, megabytes, gigabytes, terabytes, and so on. So in fact, what you do is that you will read according to a certain device, keyboard, mouse, hard disk, and so on. Meaning that you will have what? You have a buffered input stream. Then after your buffered input stream, this is like you had your store and read. Okay, just to see them over here. Now, you've seen before the part with input stream read them. So you read from a certain file. Then you also have your data input stream. You have your file input stream. So this is when you read from a file. This is the one. As well as you have your string buffer input stream. Then for it, they are in fact extending your input stream. And this is how you have them. Now you have your reader, you have your buffered reader, as you can see, as well as it exists your file reader and your string reader. And similarly, you have the one with output, as it was here, such that you will have your output stream. And for your output stream, you first need your file output stream to know where do you write. Okay, putting just the name of the file, as well as you can add this true parameter, meaning that you will do the append for it. All right. Also, you will also have the buffered output stream, as well as you have your print stream. And with this one, we print writer to write line by line. So in this case, you will write a new line according to the toString of the current object of type client. So it will call the toString method for which you did do the override. So as you can see, you've got the toString. Always you have the class name. And then you have each and every element, sort of JSON, but you don't have the two dots. Here you have it just being equal to some value. Then what it does is, in fact, that you have your file input stream, you have your file output stream, as well as you can link it to a certain file where you want to do just all these modifications. Okay, and this means that you have them in this way. You have your input output based on what? What exists here, the most abstract one, is your object. So object is also whether you have data input, whether it's serializable, whether it's throwable. So everything, they are just part of object. So for whatever index you've got, each class, you will create objects for them. So this is the most generic one and the most abstract. Such that for it, you see that you have a file. For the file, you've also got a descriptor for it to know exactly which is the type, dimension, where it is stored, which partition. Okay. For it, you will have your input stream. And for my input stream, I will have one. I can have validation for my object. I can read it. So for the input stream, it's connected to the reading, as well as for output, you have your object output. Also, For my input stream, what will I read? Well, in fact, I have everything stored at bits, so I will have an array of bits. I also have the file input stream. Okay, this one that appeared here. Then I can also do the filtering. So this is exactly like in Linux, where you've got the pipes and you can have regexes, so regular expressions that you can use, according to which you do what? You will have a buffered input stream. You also have the one with data, and maybe even you have it according to some line numbers. Also, what you have as an input, you can use pipes. Okay, so pipes means that first, what do I need? I need to have my input stream such that I can apply my pipe and obtain my output, so the desired output. Maybe I want just some substring, I have some lines starting with some prefix and I just want to see them. Also, I can see them as a sequence. So one by one, I have in fact a sequence of values. Also, I can have a string buffered input stream, which is of which type? Well, I have it as a buffer. I can simply say that, okay, it is of type char. I can also link it to a file reader, as well as, again, I can do the filtering, and it's a pushback or output or even piped. Okay, so you just read from the file. When you output, it's again the same story. You output according to what? Whether it's a byte array, you have the file output stream. So as you can see, you have these keywords in the middle which contain output. So you have the equivalent of pipe input stream as being piped output stream and so on. Also, you have the random access file. So you just take it. And how do you have it? In fact, you serialize one by one, and you serialize what exists inside the file such that you can process them and go through each and every record. For it, when I write it, what do I need to do? Is in fact, I have an object of type writer, which will do what? I have my buffered writer, even the print writer, okay, which is the one that was used over here to write. But don't forget, at the end, to persist everything, after writing, you need to close the reference, okay, or else it won't be stored. Okay. And then you've also got exceptions. So exceptions like the input-output exception, like I can have an object index input validation. Maybe I want just it to be Boolean. I can have it as an integer. By default, what you read, it's of type string because you take it from the keyboard, so it is string, and then you need to parse it, like integer.parseInt, so on. Maybe when I want to parse, I will have this invalid class exception. So it is a string. I want to cast it to be an integer, and then it will say, no, it is not of this class. As well as you can have an invalid object exception. So maybe I want to have a person of type client or address, and it is not the one for which I want to do the matching. Also, it can be inactive, or you cannot serialize it. So serialize is like this. I have a list, let's say, of elements. I store it inside the file. And then when I read from that file, I also want to obtain that list. And whether I do not obtain it, then I have the serializable exception. Maybe it's with optional data, as well as maybe inside the stream. Maybe it was a virus. You don't have exactly the character in bit code which is needed, so it won't be able to read your stream. This is like when you have Word files. So maybe they got corrupted, and then when you open your Word, it will not be able to read it. So you will have this kind of error. You can also have this end of file exception, EOF. You can also have the file not found exception. Maybe you have an interruption. This is like when you have your computer architecture programming, so whatever inside your computer, you will use by default registers. So no matter the operation, whether you have to add, whether you have to subtract, in fact, you use registers. And maybe you have an interruption, and this interruption is in fact when you have this input output. So you will have interruptions like int21h in hexa, and it will know what to do, whether to read, whether to write, or if you have another process which interferes. Then you have this to be synchronized. And when I want to synchronize, so whether I have a synchronized function, it means that process A will call process B, and whether it is synchronized, process B needs to finish such that process A will receive the result, and it will wait, and it's asynchronized whether you don't wait. So it's synchronized. Where is this? Unsynchronized. Asynchronized, it's called. Okay, asynchronous versus asynchronous. Let's see an image. Okay, let's say, okay, is this one. I have process A. It is synchronous, so it means that process A will wait until process B finishes. Okay, while being asynchronous, I have my process A, and it will continue to process, maybe read, write inside the file, or whatever it does, some statistic. When we'll have my process B, which will end somewhere in time, and it will retrieve the response. But you don't need to wait for it. Okay. Right. Then you can have the one with UTF. This is like you have in web programming. You have that UTF-8. And this is how you have each and every character analyzed, and it will be displayed for you. You also have the Char Conversions. You've got the ASCII code, which gets converted. It is like you have, let's say, inside the Word file, whether it's something in Chinese, let's say, you will have it appeared as a rectangle, and it won't be able to convert the characters. Then you also have this unsupported encoding. So maybe you store it in a certain format. You can even encrypt, as well as you can have this aborted. So whether it wanted to write inside the file and you have another client which will simply say, I don't want to do it anymore, it's been a mistake, then you will have this aborted event. Now, my input stream is what? In fact, everything is in fact a byte stream, so that I can read according to some bytes. Maybe I have some offsets, some lengths. I can even skip some characters. I can check whether I can read, as well as I can mark some lines. I can reset it. And at the end, don't forget that you need to close everything. So you will have a reader which will simply use what? You have your system in. Where did you use before your system in? Well, when you were using scanner. And in fact, it meant that you use the input of your system. So here I have my file input stream, which will read from what? From a certain file. It is exactly like the one which I put here. But don't forget that maybe the file does not exist. So it will simply trigger the error. So if I comment these lines, and I don't have even this throws IO exception, it will say here that, okay, you have two options. So you have it with more. You can add exception to method signature, which means that it's exactly what was before. But you also read line by line. So you have an input-output exception. And what you can do is, again, to put it inside here, throws. As you can see, what happens? File not found exception exists under IO exception. And you can put just one exception and you don't need your try catch. But what I can also do, I don't want to have this one. I have another option. And what you can see is that the code will be surrounded by a try catch whether the error is triggered. So it will put it here, whether it can read from the file line by line. If not, it's an input-output exception, as well as I can again surround it by a try catch. Okay, and everything will be done by your IDE. So let's return to the less lengthy code, which is this one.
Okay, so IO exception is includes the file not found exception, because this is the input-output exception. Okay, now going back. So you have the scanner, you have new scanner according to your system input, and what you can do is to also scan what exists inside your input.txt. So this is another way of reading from your file. So in fact, with this one, with the file input stream, with the buffered reader. Then, as you can see, what do? You have a certain flow based on your pipelines. So pipelines means that you get them one by one, and what you do need is in fact your input. And from where do you take it? Well, you've got the file inside your file system. So based on your operating system, you've got a file source, and what you will do is to read according to your stream one by one. So in fact, you have a flow, and in this flow, you start from the file. Then what do you have? You have your file input stream. So this is the first part. With this file input stream, you take the file, you have the first the pipeline. What it means, it's from it I obtain my bytes. Then what do I have? I have my input stream reader, and then I have my buffered reader. So here I will have my buffer input stream. Exactly, I have my buffer. And then I need to format it such that what do I obtain? So inside the memory, maybe it's of type byte, in char long float, maybe it's a string according to the toString of some objects. So exactly what I did create here. I have my class, and then I have my two attributes, IBAN and amount, based on which I have two values. And with that serializable, what it means is that I know which is the object so which is the class of the object which I want to create, as well as with what to initialize each and every attribute that I've got here. Okay. So for it, I will have my data input stream, so based on the primitive data input char, long, double, and so on. Then I will want to read it. Okay, and you will have them in this way, also that specific format. After that, you have your buffered input stream, such that you will have an array of bits that you want to read. You have your file input stream according to where it can be found. Here being for my project, as you can see, okay, it exists outside SRC. So this is my closed SRC folder, and what you need to do is to place your info.txt outside your SRC. And SRC will have what? Your main. Then you have your Java folder, and based on your Java folder, it will know how to compile everything, okay, based on the Java version that you've got, based on your Java Runtime Engine, GRE, as well as the Java Development Kit. And you have all of them. Okay. Then you can also have the string buffered input, and you can also have the pushback input, so whether you can unread a method. Okay. Now I have the output stream. For my output stream is in fact what I did over here. I want to write. So based on a file, whether I want to override it like in this way, or I have this true at the end, whether I want to append inside an existing file, again, I have my pipeline. So I need to say, where do I want to write, how. So you have an output stream writer for the bits, and then you simply write by having the toString, and in the end, you need to close it. So you write according to your bits. You can also have an offset, okay, and in the end, you have close. So it will be a file output stream. Okay, so this is what you do. In fact, you have your type, byte, in, float, whatever the type, like here I want to output a toString. Then you need to say that you format your data. After that, you have your buffered output stream, and then you use your file output stream to know exactly where do I write my byte flow. So it's inside the file. Okay, for your print writer, this is exactly what you want to write inside the class. So this is like here, I want to write a toString, which is defined over here. Okay, with the class name, which are the attributes. And in the end, to persist everything, to be saved, you have this print writable dot close. Also, you have the scanner. So scanner, it can be associated to a new file reader, according to the file where you want it to be. What you can do is to also retrieve it from the keyboard. So you have a print, and whether you want to read it, it will have this int in. This is your input, your scanner name, and you have the next int. As well as maybe I want it to be a double, so I already cast it. I know that what I will read as a string, I want it to be an integer. What I will read as a price, I want to store it as being a double. And when I want to read something like a string, let's say it's city, I simply have the next line. And even for a string, I can also call it to be next. These are the ones when you read and write from files. So it's exactly what you've seen before. So you have, again, your file output stream, whether you want to overwrite what exists or if you want to append at the end. Then you have what? Your output stream, and then you have writer. You have the name, output stream based on it, as well as you have your print writer, PW, based on which you will write a toString, and don't forget to close it. When you want to read from it, you have your file input stream, and you have this input file based on where it can be found. So by default, it looks outside the SRC. You can also put a full path. This is the relative path according to the one of the project. Then you have your file input stream, you read it, and then you have line by line, which will be displayed until you get this null reference, meaning that you did reach the end of your file. Now you have the part with exceptions, like these that you've seen with your input-output exception. Maybe the file was not found. So in fact, you see it as being as a stack. So the stack where you've got push and pop operations. So you have it one by one. So in Romanian, it's called Stiva. Okay, so it means that you have them like here, and you have the push operation, okay, such that you add. Okay, and this is called, you have the push, and then you will have the pop. Okay, pop when you will have to take out elements, push and pop, such that you will have the begin. So this means that which kind of collection you've got. It will be last in, first out. Okay, so it's a LIFO. Okay, you have a LIFO, last in, first out, as well as you have your FIFO, first in, first out. But this is the case of when having a queue or quad in Romanian. Okay. And you will have to enqueue, you dequeue, but you start with the first added element, okay, one by one. While here with the stack, you have the last one and you receive your output. So let's see what it happens. In fact, when you have a thread, so you can see a thread as being a process like here, okay, and you have, now for this process, you will have a stack. So this runtime stack, this is exactly what I want my program to do. So I put it one by one. This is like when your computer starts and firstly you have all your components checked, whether they work accordingly, and then it will continue to open one by one each and every process with a graphical user interface to call exactly your GPU. Then you will have your call stack as well as you will invoke methods. Okay, so they will be called, meaning that you will have a record as well as you've got a frame. So they occupy some slot inside the memory. And for it, whether you do have them in your stack, they will be active, as well as for all of them, you will have a stack trace. So it's exactly like this one. You have methods one by one, whether they were executed successfully, you have the pop. And if not, you see here that you have all active methods, which are methods on a stack. So exactly here inside. When you have an error, you saw that for one line of code, you have multiple rows. This is because you have this stack trace. So in fact, your error will propagate, and this is when it will be caught. So it will even trigger some lines inside some files which you didn't even write, because they belong to exactly Java and what exists inside each and every package. It is like here, I have Java IO, Java util, which at the back of it, they exist implemented. Okay. All right, so you have some lines of code. Then what you can have is to simply print some execution. So maybe you will have some to divide by 0. So maybe if I want to divide by 0, you will see that I have an arithmetic exception. And exactly, it will point also towards where it can be found. Okay, so whether I do have some error. Let's say I don't import this one and I want to run it. As you can see, you will have the errors that it couldn't find the symbols, and it will say exactly from where. So as you can see, you have this 9, meaning that I need to look at line 9, and then starting from the beginning, I will have my starting character and say that, okay, it was propagated by the fact that it couldn't find the class Gregorian calendar. Okay, so you have them one by one. And IO and so on. So they will also trigger other errors. So I will execute. And again, what I do have here is a file not found exception. Okay, which I need to look at line 53. So it will say here that the problem is exactly at this point. As well as what you can see is the whole track. So as you have here, you have the stack trace. So out of that error, you have other errors which propagated. So you have this line 53. Then you have an input-output exception at line 63. So you double click on it and it takes you there. It couldn't find your file output stream at line 53 and so on. And these are the ones that will be shown. Okay, so this is how you can follow each and every error that appears. So out of 1, you will see that you have multiple errors. Okay. All right, going back. So how do you deal with these errors? You simply have to also, as here, whether they are thrown with this throws file not found exception, you need to edit, so it will appear like here. You have an unhandled exception, so or you do it with a try catch, or you add it in the method signature. But this one will be done automatically for you, so you will be helped. You don't need to remember by heart. Okay. And also, you can even classify them. So whatever the error, they will be throwable. Then you can have them as being the unchecked exception. So as you can see, you have it of type error. And then you will see that for this exception, you have your input-output exception, okay, which is checked. So you know exactly for my exception, which is exactly the type for it, it will be one of, so they are checked exception for my exception. I know which is the type for it, so even for the error. Okay, so you know exactly which will be the type. It is not a generic one. So it is like here, I have object, I have what? I have throwable based on my exception, which are the types. Maybe the file was not found, maybe it's an illegal access, maybe it was interrupted, the method does not exist or no such field, as well as for the runtime, maybe I have my arithmetic exception, whether I want to divide by 0. I can have an array store as well as an illegal argument that I cannot add, whether it's also on its format. I can have an illegal state exception based on the monitor. Maybe it's also index out of bounds. So maybe I have an array. I want to check for a certain position, but it doesn't exist. And it will say whether it's an array index out of bounds, or maybe I have exactly a string which is an array of chars, and it will also say that it exceeded the bound. Maybe it's also an array of a negative size, okay, as well as you can have a null pointer, so maybe it doesn't exist, or maybe whether even if it's based on rights to be a security exception. Also, so again, I have object throwable exception, which is this part, and I can also see it as being of type error. So this is the unchecked. I don't know which is exactly its type, but I can have them checked by having each and every type right here. It can be linked, so whether it's a class to be circularly, so if one class depends on another, I can have the format, whether when I initialize it, it's not compatible, or maybe I have an error, like I have an abstract class that I cannot call. You've seen like for my account to withdraw, which is exactly here. I cannot call it to have a lab1 card.withdraw. It simply needs to have exactly the logic behind it. So I need to override the method as it was done over here. Then maybe you access some private parameters. So it's an illegal access. Maybe when you want to initialize, so this instantiation error, this is like when I have lab1 card equals lab1 new lab1 card, which you cannot do because it is abstract. And this is why you need to make them of debit card or of credit card as it was done here at the end. Okay, so you can instantiate them in this way. Then you can have also some fields which do not exist, methods which do not exist, also some class definition which was not found, so whether you should check some error, as well as maybe your thread dies, so the process, and even whatever you run, your Java code, so it runs no matter the system, the same code, you don't need to modify it, and Java runs inside a virtual machine. And maybe this virtual machine will have some internal error, or maybe you don't have any more memory, as well as you can have a stack overflow, meaning that you have multiple processes and one depends on another. So out of one line of code, so it will simply propagate. It is like here, if I don't import for this file output stream, and whatever depends on it, the error will propagate, and you will have a lot of lines, as you can see, just because of not importing java.io. I have 17 lines of errors when everything could be solved just with adding this one line of code. Okay, so for my input-output exception, in fact, you will have the file with end of file exception. Maybe it wasn't found. This is what you've seen exactly before, okay, which was explained. Okay, these ones. As well as the string. Maybe it's corrupted, you cannot serialize it. So maybe even for my IBAN that I store inside the file, maybe it's not lab1 card, but it's written here with person, and you cannot serialize it to have it as an object. Okay, for this throwable. So in fact, when you have it with throwable, it will in fact have inside the throwable for it based on message to get a message, as well as I have my print stack and to display it. Okay. All right, so I will have the print stream and the print writer. Right, such that even if I go here inside, and I don't want to have this one, but I want to import them one by one. Okay, let's see. I want to have this one import class. So what I can do is to also go to definition, annotation. Okay, so this is what you see in fact inside. You have your Java development kit, and what Java does for you is in fact to have all these functions defined. Okay, so this is because of not having them, you will simply have an error. Let's see. So going back. Right, and I import the Java IO. So in fact, you have all these files that depend one on another. And what you see here, you have your print stack trace. So in fact, you will see something like this, all your errors, which in IntelliJ they appear in this way, while in NetBeans Eclipse they appear well, like one under another, and it's more difficult to read. Okay. Also, you also have the declare checked exception, meaning that you have exactly the throws. So you know that at runtime, I will have what? I will have a file not found exception. Or maybe I have an array and I have a position of -1, which will trigger an index out of bounds exception. Or maybe you have some object which is null and you cannot access it, so you will have a null pointer. It is like here, you have already a checked exception and you know exactly which one will be thrown, whether it's a file not found or whether it's this one, input output. Okay, and you can have the throw. So this is exactly what you've seen. And now here for my exception, whether it is thrown, I want to see exactly the print stack trace, which is provided by Java. Or what you can do is to say exactly which is the message, but I don't advise you to write your own exception. It's better to see the one provided by default. Okay, so you can do it this end of file, or what you can do is to see which is exactly the dimension of your array based on which I want to provide my position. Okay, so you can simply have the throws, and as you can see, we'll have this throw new. It's exactly as you've seen it here. Okay, to catch it based on its type. Okay, so you have try catch according to whether it's an exception, whether I write it according to a previous definition, an error according to an error type. Okay, so what you can do is either way. You write it as being a public static read string. So you do the try catch, exactly the try catch which you've seen here. Or what it can do is to have just these throws. So if I have just these throws and I don't put this try catch, it will still work. So as you can see, no error and it's fine. So you can do it either way. Okay, but here you have 2 in 1, so I prefer to see both of them. Okay, and this is another. This is just to catch it according to your exception, input output, and you have the print stack trace. So it's exactly this one that you see. Okay, as well as you have the throws. So it's exactly as before. Try catch. So I can have the try catch of IO exception and I print the stack trace, or I can put it over here and to have throws of my exception. And either way, I can have multiple try catches. So based on try, I can have maybe it's a parse exception, input output exception. Okay, I can have another parse exception. Or what I can do is to mix them up. And it can be either parse, either IO of exception, and I can call to print the stack trace for them. So you can merge them, not to have catch, catch, catch of each and every type. Okay. And here it is whether you want to have your IO exception. Okay. When I want to write inside the file, and I have this true, meaning that I append, and then I will have the toString. But don't forget, after writing, you need to close. Okay, it is exactly like here. Okay. And what you can do is to also have it to stop it. So maybe my dimension of a planet is less, so it can have a negative value. And whether I have a negative value, I can throw an exception called illegal argument exception. And thus, you don't use the print stack trace, which is provided by default. Okay, but so to see something like this, but you say exactly that the dimension should be positive. And in this way, you have exactly the user and also the coder who will know what you mean by its dimension, what to check. You can also assert, so you can check whether or not you have a value to be false. So you will say that it shouldn't be reached. So exactly, it can be a switch based on several cards. And let's say I have a suite of clubs, diamonds, hearts, spades, and I will have the default, and it will simply have to assert false. So this means that when you want to check whether or not, it will be, for example, false, and you will have an answer. Okay, so this is how you can do it. So that's it for today. Let's see if you have any questions.